And now, over 13.8 billion years later, we find ourselves on a small, rocky world orbiting an ordinary star, asking the question that seems almost too vast for minds shaped by biology and bounded by mortality. The end of the universe is not a single event, but a journey. A long, slow unfolding of fate, governed not by intention or design, but by the cold and elegant laws of physics. And to see its end, we must first understand its shape. The universe, on the largest scales, is expanding. Not into anything, but expanding itself, space stretching, galaxies drifting apart not because they are moving through space, but because space itself is growing between them. This expansion was discovered in the 20th century, and for a time we thought gravity, the great sculptor of structure, would slow it down. Perhaps, one day, the expansion would stop, reverse, and collapse back into a big crunch. But the universe had other plans. In 1998, observations of distant supernovae revealed something astonishing. The expansion of the universe is not slowing down, it is accelerating. And this acceleration is driven by something we do not fully understand. We call it dark energy. It seems to be a property of space itself, a kind of energy woven into the very fabric of the cosmos, pushing galaxies apart with increasing force. If this dark energy remains constant, or grows stronger, then the universe is headed for a fate known as the heat death. It is a poetic name, masking a desolate reality. As galaxies rush away from one another, their light redshifts, stretched by expansion into longer and longer wavelengths, until they become invisible to any eye. The sky will grow dark, not because the stars have died, but because their light can no longer reach us. Over tens of billions of years, star formation will slow. The fuel, hydrogen and helium, will be used up. The last stars will be born, long, slow-burning red dwarfs, glowing dimly for trillions of years before finally fading into black dwarfs, dark, cold remnants of once luminous suns. Black holes will dominate then, swallowing the remnants of stars, tearing apart matter with tidal forces so intense they warp space-time. But even these monsters will not last forever. Through a process known as Hawking radiation, black holes will leak energy, slowly evaporating over unimaginable timescales. A stellar mass black hole will take 10 to the power of 64 years to evaporate. A number so large, it dwarfs the age of our universe into irrelevance. In the end, what remains is silence. No stars. No black holes. No light. Just a vast, thin, dark universe, filled with particles stretched to the edge of nothingness, drifting in a space that is ever colder, ever emptier. This is the heat death, a universe that has reached maximum entropy, where energy is uniformly distributed, and no more work can be done. Time continues, but nothing changes. It is a final, quiet, eternal equilibrium. But it may not be the only fate. There are other possibilities, some more violent, some even more exotic. One is the Big Rip. If dark energy is not constant, but increases over time, then the repulsive force it exerts will grow stronger and stronger. Eventually, it will overcome the gravity that holds galaxies together. Then it will tear apart stars. Then planets. And finally, atoms themselves. The universe will be pulled apart at the most fundamental level. In the last moments, even space-time could be ripped into fragments. This could happen in 22 billion years. Or never. It depends on the nature of dark energy, something we are only beginning to glimpse. Then there's vacuum decay, a chilling possibility from the world of quantum physics. It is possible that what we call empty space is not in its most stable state. That the vacuum of our universe is a false vacuum, a temporary condition, like a ball resting in a shallow valley, unaware that a deeper one lies nearby. If a quantum fluctuation were to nudge the universe into this true vacuum, it would trigger a bubble of new physics, expanding at the speed of light, obliterating everything in its path. The laws of nature themselves would be rewritten in an instant. And we would never see it coming. It is a reminder that the universe is not obligated to be comforting. Yet amidst this cold and indifferent future, something beautiful remains. We are here. We are the universe contemplating itself. We are made of matter forged in stars, shaped by gravity, governed by quantum fields, and still, somehow, able to ask these questions. To wonder not only how things are, but how they will end. And perhaps that is enough. Because though the end may be darkness and silence, the story that came before, the galaxies, the stars, the blue worlds and living minds, is full of light. The universe will not end with fire, nor with sudden destruction, but with a long, slow fading into night. And in that final silence, what remains is the echo of understanding. A whisper carried across time. That for a brief moment, in the vastness of eternity, there was a species that looked up, and knew what it was made of.